The sun is a lot of things: life-giving, sustaining, beautiful. It's also a bit of a diva. Every day it throws a massive tantrum, hurling over 100 million atom bombs worth of solar flares at us. That might sound scary, but these solar tantrums have been happening since the birth of our solar system, and they'll likely keep up until the sun dies. So we are used to them. In fact, we can predict them so well that satellites can take evasive action when the sun gets a little too angry. And sometimes these bursts of solar energy can even be beautiful. When it hits our atmosphere just right, we get an amazing natural light show known as the aurora. But what if this celestial body wasn't such a ball of hot gas, but something else entirely? What if the sun was a disco ball? Well, let's find out. How would we even tell if the sun was a disco ball in disguise? The sun is 400 times wider than Earth and sits 150 million kilometers away. So while it looks like a tiny ball in the sky, it is actually much larger than anything else in our solar system except for the cloud of dust and gas that surrounds it. Known as a solar nebula, this outer layer of our solar system is around 100,000 times the size of the sun itself. If you were shrunk down to the size of a proton and launched into deep space, you would fly straight through the sun, exiting it at the other side without ever hitting anything. You wouldn't even notice anything unusual until you reached the boundary of the solar system. There you would begin to see strange things. You'd find comets and asteroids hurtling through space in strange orbits. These chunks of rock and ice are leftovers from the formation of the solar system, and they have a hard time sticking to any kind of path because there isn't anything in space strong enough to hold them in a stable orbit. They could be nudged off course by the gravitational tugs of passing stars or wandering interstellar spacecrafts. Or they could stay in our solar system's middle orbit, dancing around the sun indefinitely. At first, you wouldn't be able to tell where the sun was, but after about 2 hours and 40 minutes of flying, you'd see a faint glow on the horizon. As you approached, the glow would turn into a brilliant light, blinding you completely. If you were still alive, you wouldn't be for long. The sun's radiation would rip apart your atoms, killing you instantly. So to answer the question, you couldn't really tell if the sun was a disco ball without getting very close to it. And if you got close enough to tell, you'd be dead before you could send the message back to Earth. But what if we had some way to get around these pesky facts? Like maybe we found a way to shrink ourselves down to the size of protons without dying in the process. Now the sun is made up of hydrogen and helium, which are two of the simplest elements in the universe. This means that if we were small enough, we could simply walk inside the sun. No more rockets, no more radiation. We could explore the inner parts of the sun and see exactly what's going on. When you shrink yourself down to the size of a proton, you're about 1/10,000th the width of a soccer ball. At this size, you would be small enough to see the individual atoms making up the sun. But this journey would only take us so far. Sure, we'd be able to see the sun's swirling layers of hot plasma, and maybe we'd even spot a solar flare or two, but we wouldn't be able to tell if the sun was a disco ball. We'd only make it about 2 centimeters into the sun before we hit the core and all the answers we seek. Here is where nuclear fusion happens, the process that powers the sun and all other stars. Simply put, this is where hydrogen atoms combine to form helium, releasing tremendous amounts of energy in the process. But while walking through the sun, we wouldn't be able to tell that anything special was happening at all. We'd only see balls of hot gas moving around us. We would need a way to look inside the sun to see if it was a disco ball. There is a solution to this problem. Scientists have managed to peer into the sun's core by detecting neutrinos. These tiny ghost particles zip in and out of atoms, allowing them to pass through solid objects like lead and concrete. In fact, trillions of neutrinos pass through your body every second, and you don't even notice. Using neutrino detectors buried deep under the ground, scientists are able to see inside the sun. One neutrino detector called Super Kamiokande is a huge underground tank filled with 50,000 tons of ultra-pure water. When a neutrino collides with a water molecule, it leaves behind a tiny flash of light. By measuring the direction and strength of these flashes, scientists can learn more about what's happening inside the sun. Recently, they used neutrinos to confirm that the sun's core is a raging ball of plasma. It's about 15 million degrees Celsius. This helps prove that nuclear fusion is happening and giving off the light and heat that sustains life on Earth. So we can see inside the sun. But would that help us tell if it was a disco ball? Not really. We'd probably just see a bunch of random particles flying around, not the giant mirror ball we were hoping for. And even if we did see a mirror ball, it wouldn't do us much good. We'd be stuck inside the sun with no way out. Okay, so the sun isn't a disco ball. But let's say it was. How would that affect our solar system? Let's imagine a scenario where the sun was a gigantic disco ball orbiting Earth. Every time it spun around, the beams of reflected light would sweep across our planet, bringing with them the infectious beat of the cosmos. Plants would soak up the rhythm and sway to the music. Animals would dance in wild abandon. Humans would throw off their inhibitions and move as one. Of course, this disco fever dream would quickly end. The sun is 400 times wider than Earth, which means its gravitational pull is much stronger. We could never get close enough to it to actually use it as a disco ball. Plus, the sun doesn't reflect light. It emits it. So even if we somehow got close enough to it to hang our disco ball, it wouldn't do us much good. We'd just end up blinded and roasted alive. Maybe we could use the sun as a disco ball if we left our solar system. Astronomers have discovered thousands of exoplanets, planets outside of our solar system. Some of these planets orbit stars similar to our sun. Others orbit stars smaller and cooler than our sun. Some orbit stars bigger and brighter than our sun. Maybe if we went far, far away, we could find a star that would work as both a life-giving orb and a disco ball. But even if we found a perfect star, how would we attach our disco ball to it? Stars are constantly emitting solar winds, streams of charged particles that blast away from their surfaces at high speeds. These winds push on anything that gets too close, sometimes knocking smaller objects out of orbit. If we somehow attached our disco ball to a star, it wouldn't stay there for long. The solar wind would blow it away. We could try to solve this problem by using a very powerful tractor beam, a force strong enough to hold the disco ball in place despite the star's constant solar winds. But here's the thing. We don't know if this is even possible. Our physics is based on the laws of gravity, electromagnetism, and the strong and weak nuclear forces. All of these forces have been measured and quantified. In fact, we know the exact strengths of all of them. However, we don't know how to combine these forces into one single equation. We call this the holy grail of physics because solving it would revolutionize the world. It would allow us to develop new technologies like warp drives and tractor beams that could defy the laws of physics as we know them. Until then, we'll just have to stick to what we know works. And right now, the best way to use the sun as a disco ball is not by hanging one above our heads, but by putting on sunscreen and enjoying the beach. After all, the sun gives us life and light. And without it, we'd be stuck in a never-ending night.